Welcome. Today we're doing the Chapter 13 study guide for the test. Okay, question number 1. How many different dinners can be made by choosing one each of 6 vegetables, 5 meats, and 3 desserts? Well, how many tells me it's counting. So I've just got the counting principle, which states that if you can do M and N and K things, it's M times N times K. The short version. Okay, so that just means it's going to be 6 times 5 times 3. Well, let's see. That's 30 times 3 is 90. So my answer is B. That wasn't too bad. Find the probability that A occurs given B has occurred. All right, if you recall, we had an equation, and it was that the probability of A and B is equal to the probability of B times the probability of P given, not P, sorry, of A given B. All right, so what we're looking for then is this guy. So we're going to solve for that, and what we do is we take this guy and divide both sides by him. So now this is going to be over here underneath the probability of A and B. And they gave us all that information. Okay, so that means that the probability of A given B is equal to the probability of A and B over the probability of B. Well, in this case, that's 0.2 over 0.7. We put this in our calculator. 0.2 divide 0.7. And we get 0.2857, which is 0.286. So our answer is 0.286. All right, you should be writing this formula on your formula sheet, okay? You can also write this. The thing to remember is this changes according to the order of A given B. If it had been B given A, then this would have been the probability of A, okay? So it's whatever in the A given B in that part, the conditional, basically. In the conditional probability, whatever comes second, that's this probability. Okay, so just remember that. Calculate the probability of exactly 2 successes in 6 trials of a binomial experiment. Okay, first off, binomial. So when they say to do that, it's NCX times, P to the X, Q to the X minus, N minus X. All right, so in this case, N is the total number of experiments, 6 trials. X is the number of successes, so that's 2. P is the probability of a success, in this case 0.3. Q is 1 minus P, so in this case it's 0.7. Now we just plug this in. All right, so we're going to put in our calculator 6C2 parenthesis 0.3 to the 2 times 0.7. 6 minus 2 is 4. That's what we're putting in our calculator. You're just plunging it into the formula. Again, something you should be putting on your formula sheet. There's a spot for it. All right, 6, math, arrow over to probability, number 3. That gives me 6C, and then I put in a 2. I right arrow out of the subscript, parenthesis, 0.3, close parenthesis, squared. Step out of the exponent if you're up there, parenthesis, 0.7, close parenthesis, to the 4. When I say to the, I mean that little caret symbol, the one that looks like this. It's directly above the divide button. Okay, enter, and I get 0.324135. So my answer is 0.324. There we go. Okay, those are formulas you should have. You want to put those on your formula sheets. Please don't forget. All right, an experiment consists of drawing a number from 1 to 40 out of a hat. Find each probability as a percent. Okay, so that's what our answer has to be. You will get marked off if you don't give me a percent answer. All right, drawing a single digit. Well, how many single digits do I have? It says 1 to 40. So I have 1 through 9, which means I actually have 9 single digits. So it's going to be 9 over 40. All right, so I have to put this into my calculator. And I get 0.225, which is 22.5%. That's the answer I want to see. I would also expect to see the rest of this. This is just one of the problems you have to show work. You can't just give me an answer. All right, drawing a number less than 20 or greater than 45. How many numbers do I have less than 20? Well, that's going to be 19 numbers less than 20. Greater than 45, 35. That should have been changed to 35. It's going to be 36, 37, 38, 39, and 40. So I have 5 numbers greater than 35. So my answer is going to be 19 plus 5 over 40. That's 24 over 40. So I'm going to put that in my calculator. I expect to see all this writing on your paper. Just give me answers. I can't help you if you get anything wrong. All right, this is 0.6, which gives me 60%. Again, that's the number I'm looking for. Drawing a number divisible by 9. Okay, what's divisible by 9? Well, we have 9, 18, times 3 is 27, times 4 is 36, and anything after that gets above 40. So you can see I have 4 numbers. So my answer is going to be 4 over 40, which is 1 over 10, or 0.1, which gives me 10%. All right. So what are the coefficients of the expansion of x plus y to the 6th? Now, notice that they have no coefficients on x and y. So my coefficient is just going to be Pascal's number, right? So it's just really, they want to know the 6th line in Pascal's number triangle. So we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, hang on. Okay. Yes, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. 6th line, there we go. Okay, so I want to see a list. I need commas between them. That would be what your answer should look like. If it doesn't, you'll lose points. All right, a number cube is rolled and then a marble is drawn from a bag. Okay, the marble, so number cube is drawn. So for the number cube, I have 6 possible answers. For a marble, it has 4 red and 6 blue, so 4 and 6 is 10. So I have 10 possible marbles I can pull from the bag. All right, so what is the probability of rolling a number less than 3? So how many numbers do I have less than 3 that are on a die, a number cube? 1 and 2. So I have a total of 2 numbers. And drawing a blue marble. How many blue marbles did I have? 6. It's an and, so it's a multiplication. Well, let's see. The 6's cross out. The 2 crosses out with the 10, leaving a 5. So my answer is 1/5, which is 0.2. So there's my answer. All right, moving on to the next page. Whoa, what did we do? Oh, I think I went back. All right, the following prizes are given to the first 1,000 customers at the state fair. Okay, when you're talking about probabilities now, that means I'm going to have a 1,000 denominator because there's 1,000 possibles, unless I have a given situation. What is the probability that the first person to get a prize receives $10? Well, that's 1,000 possible prizes. And how many $10 bills are given out? 20. So I have 2 100ths. 0.00, nope, not the second 0, just 1 0. Tenths, hundredths. Okay. So the answer to this is 0.02. What is the probability that the last person to get a prize receives $10? Well, it's actually very simple. It doesn't really matter where in the situation, where in the process you are. Your probability is still going to be 2%. So it's the exact same for both of these. All right, find each probability to the nearest 10th of a percent when randomly drawing from a hat containing 24 cards, each with a different letter of the alphabet, excluding Y and Z. So it's the first 24 letters of the alphabet. To the nearest 10th of a percent, what random drawing... Okay. 2 consonants. 2 consonants in 2 draws. Okay, we still first have to figure out how many consonants we have. Well, there are 5 vowels, right? There's A, E, I, O, U. For Y is not in there, so we don't need to worry about it. So we have 5 consonants. 5 vowels, 24 cards. So we're going to have 19 consonants. I'm not going to write it all out. In fact, oons, whatever. Okay, 19. So probability on the first draw is this, of drawing a consonant. Now, for my second draw, it is not replaced. Therefore, I have fewer cards. So now I only have 23 cards. But if I've drawn a consonant, then I really only have 18 consonants left in my 23 cards. So that's the probability of getting a consonant and a consonant. B, I'll finish that in a sec. No, I'll finish it now. Okay, so this we're going to put in our calculator. Parenthesis, 19 times 18, close parenthesis, divide parenthesis. You have to put the parentheses in or it's not going to get you the right answer. 24 times 23, close parenthesis. All right, 0.61956. Okay, so to the nearest 10th of a percent. Percents, that means I need percent answer. So 61.9, it all rounds up to 20, 62%, right? Because the 5 would round the 9 up to 10, so it's going to change that one. So I have 62%. All right, what I was starting to say about the consonants is I only have 4 ways I can pull out 2 cards with consonants and vowels. I have 2 consonants. I have a vowel and a consonant. I have a consonant and a vowel. Whoops, that second consonant vowel. Or I have 2 vowels. So drawing at least 1 vowel in 2 draws if the first card is not replaced. So that's the same as the previous one. At least 1 vowel, well, that's going to be all 3 of these situations. It's going to be a vowel consonant, a consonant vowel. Those have 1. But since it says at least 1, it's okay if I have 2. So really, it's just a complement situation. I'm just looking for the complement of the previous. So this is going to be, what, 78? No, not 78. 28, sorry. 38. 38. I'm trying to do it in my head and not doing well. Okay, 38%. 73. Yes. Okay, that would be my next anyway, okay, so that's done with that half. Let's go look at this. Yes, I did. Okay. Find each probability to the nearest 0.1% if marbles are randomly drawn from a bag containing 6 blue and 10 red marbles. Drawing 2 marbles of the same color if the first marble is replaced. All right, well, for the first marble, so actually, let's see what we're looking for. We're looking for 2 blues because it's same color, or 2 reds. So these are 2 different situations. So what I have is the probability of 2 blues plus the probability of 2 reds because it's one or the other. So it's added. All right. So the first marble is blue. I have 6 blue out of 16 marbles. The second marble is blue. Well, I only have 5 blue left. And no, sorry. I actually have 6 again because it's replaced. And reds, I have 10 reds. Okay. So I have 36 plus 100 over 16 squared. 16 times 16 because it's a common denominator. So I have 136 divide 16 squared. And I get 0.53125. You should be checking with your calculator all along that you're putting these in correctly. Because just because I'm doing it correctly, if you're not practicing it, you're not going to do it correctly. So you need to be practicing along with me, making sure you're getting exactly the 0.53125. I'm trying to talk you through how I put it in, but you have to practice. So this is 50 to the nearest 0.1%, so 53.1%. All right, drawing 2 marbles of the same color if it's not replaced. So same situation with the change of replacement. Okay, so the blues are going to be 6 over 16 for the first one, but now I have 1 less blue and 1 less marble. And same with the reds. They're the same for the first, but I have 1 less red and 1 less marble. All right, so that's 30 and 90. That's 120. over whatever 16 times 15 is. So that's what I'm going to put in my calculator. 120 divided by parenthesis, I have to put this in parentheses or it's not going to come out correct. 16 times 15, because PEMDAS will move it out. All right, is 0.5. So this is 50%. Okay, so, I was going to tell you, if you don't put that parenthesis on the bottom, what you're actually typing in would be this. Give you a completely different number. All right, drawing one marble for each color. Oh, of each color, if the first marble is replaced. So this is like A, or is replaced. Now, how many ways can I draw two marbles out of this bag? I can draw blue, blue. I can draw red, red, which I've already accounted for. Or I can draw red, blue, or blue, red. Those are the only possibilities. Therefore, that's my sample space. The first half, the top half here, the BB and the RR, I've already taken place. So all I really need is 1 minus, because it's a complement, 53.1. Actually, it's 100 minus 53.1 in the percentages, right? Okay, so 100 minus 53.1, and I get 46.9%. This has the same situation. Again, now it's saying not replaced, just like B. So B was 50%. So my answer is going to be 50%. Okay. Pretty easy. A school issues each student an ID with a unique code consisting of 3 letters followed by 4 numbers. So what do we have? We have letters. And how many numbers? 4. 4 numbers. 1, 2, 3, 4. All right, how many ID codes are possible if letters and numbers may be used more than once? So duplicates are allowed. That means I have 26 letters each time. And I have 10 numbers, 0 through 9, each time. So this actually ends up okay, so 26 cubed is 17576. 1, 2, 3, 4. 175,760,000 possible ID badges. Not bad. All right. 2 more, I think, on this page. Yes. All right. Many college honor societies are named using 3 Greek letters. Use the fact that there are 22 letters in the Greek alphabet to complete the following. Okay. How many society names can be formed in each case? Letters can be repeated. They're 3-letter society names. So I've got 22. If they can be repeated, it's just 22 cubed. This is how many, so it's just counting. So, 10648. That's all it is. All right, all 3 letters must be different. Okay, well, 1, 2, 3 letters. The first time I have 22 choices, the second time I have 21, and then I have 20. Just so you understand, this is also 22P3. Sorry. Same number. Same calculation, as a matter of fact. 22 times 21 times 20. 9,240. If they can't be repeated. But we know they can. Because there are things like kappa delta kappa that have both one letter repeated. Okay, expand x minus 3 to the 5. All right, so I have my first row is my first term, second row is my second term, and then Pascal's triangle. So I have x to the 5, x to the 4, x3, x2, x1. X to the 0 is 1. All right, and because I don't need the 1, I'm going to get rid of it. Just less stuff makes it less confusing. Now the second term has to go the other direction. So this is going to be -3, well, to the 0. So that's 1. So that's 1. -3 to the 1 is -3. -3 squared is 9. -3 cubed, -3 to the 4th becomes positive again. And -3 to the 5th is negative. Pretty sure that that's what it is. 3 to the 5th. Nope, 243. I was off. Sorry. 243. All right. Now my Pascal's triangle, I'm looking for the 5th row. Well, you know what? I already did that, didn't I? Okay, let's see if I can remember it. 1, 5, 1, 5, 10, 10. Yep. All right, now I multiply down the columns. 1 times 1 times x to the 5th, so I start with x to the 5th. 5 times 3 is 13, and it's a negative x to the 4th. 10 times 9 is 90, x cubed, minus 270x squared, plus 80, whoops, not 81, 81 times 5. 162, 324, plus 81, or 405. Okay. X and minus, give myself 2, 4, 3. So that would be my expansion. Okay, so hopefully this is not too complicated. I try to stick to just 12 questions. Let me know if you have any questions. And good luck on the test. And actually, this is our last test. So once you take this test, I'll maybe see you next year. Have a good summer. Okay, bye-bye.